Okay, so we're talking about variables and assignments this week. This is kind of the basics of how we assign things in Java. Now keep in mind some of the stuff we discussed last week about locations where variables are stored. When we actually create a variable, behind the scenes, it's taking up a place in memory. It's actually assigning it in RAM physically. So a variable, this is just nothing more than a named item. You could use X or say the number of people, and then you're assigning it a value. An assignment is taking a value and assigning it to a variable, such as when we look at like X equals 5. Assignments, you're going to use these all the time. Assignments are always left signature, meaning whatever is on the left-hand side of the equation is always the way you assign things. It's not like algebra where it could be assigning to the right. It's always left-hand assignment. So for example, if we declare a variable, say int as the type, and the variable is X, we've declared int as the type and the variable is X, and we say that X equals some number. So it could be X equals 5, or we could have Y equal 5, or so forth. And then we can take those variables and we can add them together, and again, it's always left assignment. That's going to be very important as you look at how you code. The equal sign is not the same as equals. Okay? The equal sign in Java is a left-sided assignment. It just says take this value and shift it over here. Assign it to this variable. So you might be used to that in algebra class or geometry or whatever, right? Thinking that 5 equals 5 is an equality statement. Not so in Java. If you want to do equality statements in Java, you have to use double equals, okay? 2 equal signs. So when we're assigning with a variable on the left and not the right, because in programming, equals always means assignment. All right, I keep saying that, but hopefully it's going to stick in your brain here. Equals always means assignment. A variable may appear on both sides. So for example, we could have X equals X plus Y. And what we're basically doing then is taking whatever is the value of X, adding a number to it, and then reassigning it to itself. You can increase the scope of a variable, increase the amount of a variable by doing that. And as you can see here at the bottom, we got it highlighted. This is commonly how we increment variables. We have 2 terms we use in Java for adding to something and either taking something away. We use the term increment to add to something, and we use the term decrement to take away. So you're going to see that. A decrement, as you can imagine, uses what type of mathematical operator? Yeah, a minus, a subtraction symbol. Whereas an increment will always use a plus. And in Java, you can also do things where you combine the equal operator with a incrementer. So you could say x equal plus 1. And that's automatically taking the value of x and adding to x plus 1. It's the same as what you see right here. If I was to say x equals plus 1, skipping this symbol, it's exactly the same. All right, so we have variable declaration. And I already hinted at a variable declaration a moment ago, but in Java, every variable that you create, it must be specified by a type. Now, when you get into, we're using JDK 17, and as of JDK 10, we have a special variable type called var. But for right now, everything you're going to be using is going to be looking specifically at a strongly typed variable. When I say strongly typed, it means that you're specifying the type in front of the variable declaration. Okay, anybody confused about that? Okay, so in this instance, I'm creating an int type of variable called my age. And as you can see, it has a semicolon. That's totally valid. Now, its inferred value is what? Is 0. Exactly. We don't really want to do it this way. We always want to specify our types. Now, you're going to be using the scanner class some more, and so it's going to be part of the process of declaring your types up top and then using your scanner to populate or to assign those. But we'll get into some examples of that today in your lab. Initializing variables. Here you can see that we've declared the type of max score. It's a type of int, and we've assigned it the value 100. And you can as well. You could say int max. Well, you could declare int max score equals 100, and then right below it you could say max score equals max score plus. You could even say scanner dot next int, which would then read from the keyboard, assign it, and add it together and assign it back to the max score. Some common errors that you need to keep in mind. We just talked about this, that it's always left assignment. Inevitably, someone will try to do it in reverse. Well, they'll say, well, num kids plus num adults equals num people. You can't write it that way in Java. You have to write it where you say the variable that you're going to assign to. So in this case, it would be what? Exactly. And the same scenario with 9 equals bean count. We would want to reverse that. So as a rule of thumb, assignment is always which direction? Left. Perfect. If you tried to write this in IntelliJ, IntelliJ wouldn't even compile it. It would just say, I'm sorry, I don't know what you're trying to do. That's just silly. We don't talk like that in this class. That's what it would tell you. All right, anyways. This can be kind of a hard to find bug if you wrote your code wrong, because you'd look at it and go, oh, it looks right to me, but it's always remember left assignment. Okay. So we have some rules about what we name things. I had a dog, and in my family we made a rule that we'd always name our dog after some Star Trek character. That was our rule. So we had a boxer bulldog in Kentucky, and we named it Kirk. No, I'm sorry, we named it Tiberius. Does anyone like Star Trek? Anyone know where I'm going with this? Okay. Anyways. Here in Saipan, we had another dog, and we named it Kirk. And so, there's rules for the way you name things. There's maybe a rule in the way that your family names things. Well, it's the same thing here in Java. There are rules that the Java language applies. For example, the name must be a sequence of letters. It could be a sequence of underscore, dollar signs, and digits. It can never, ever, ever start with a digit, though. You can't create a name in Java where you say one student. That's an illegal name reference. You can't do that. However, you can use the dollar sign to start with the name. You can use the underscore. You can use any lowercase symbol. Now, typically, it's not good practice to name things with the dollar sign or the underscore. Usually, as you advance in Java, let's say that you decide to stay in programming in Java for a lot of years like me, you'll see some APIs in programming languages that actually self-interpret and create variables like that. But in general, we don't do that. Always make your variables meaningful. Meaningful in what they represent and what they do. Okay? Let's go on. All right, so identifiers, they're case sensitive. If we were to look at these two right here, and you were thinking, well, in Windows, this is okay. Well, not in Java. In Java, everything is case sensitive, meaning it has to match the exact uppercase, lowercase that you create the variable. So you may, and I think some of you actually, when you reached out to me this last week, one of you did, you had the variable name, just a capital letter added, and it's very easy for us to not catch that, but always pay attention to how we do things. We also can't name our variables anything that is a reserved keyword. And I have a whole list of reserved keywords. There's many reserved keywords that you can't use. For example, you can't use for. You can't use any of the typed variables like int, long, double, float, integer. There are several. You can't call a variable string. You can't say string. It's illegal keyword, right? Well, we'll just take a look at these real quick here. These are the keywords you cannot use. And it's important that you remember this. This list, I don't see it on here, but the new keyword that's been added as of Java 10, of course we're already at Java 17, is the keyword var. So any of these, and by the way, you will see these probably on a quiz or a test later on. So make sure that you know the keywords that you cannot use. These keywords are used for various purposes in Java within the language. Okay? You understand what I mean by keyword, right? So for example, you couldn't say int class equals whatever. You couldn't do that. You'd have to say int my class or int, right, something else, or string my class. But you couldn't use just the keyword class itself. Yes?
Can we use true or false in there?
No. True or false are considered values in Java. Yeah. Okay. So you will see this in Zybooks this week. If some of you have already started, you've probably already ran across it. But also remember that the keyword var you can also not use. Okay. Style guidelines. We use a thing in Java called camel case. You guys know what camel case is? All right, so if you're looking at a camel, you see the humps on the back, right? And think about how you would write that in with letters. The way you would do that with letters is, for example, on each of your desks, you have a sign that says keep your distance. If I was going to convert that into a variable with camel case, someone tell me what it might look like.
It's all together, so lowercase k.
Uh-huh. It's right in front of you.
And then capital Y and then capital D.
Yep, exactly. So you'll take the words, you'll smush them together, and you'll usually take the second and third word and make those uppercase. Okay, that's called camel case. There are some people who think it's funny to do reverse camel case. It's not funny. It's hard on the eyes, especially after you've been used to reading camel case for 14 years. It's, yeah. Anyways, another thing you can do in Java is you can separate words by underscores. We want to reserve those types of variable names for anything that's static or final. So we'll get into magic numbers and things like that later in class. And anytime you have a magic number or a magic variable, we call them magic because they don't change. We wouldn't want them to change, and so we want to declare them as either final or static. And we would basically, instead of using camel case for those variables, we'll do them like this. Any questions? Okay. So good practice to create meaningful identifying names that self-describe an item's purpose. So if I had a bookstore, and in my bookstore, I had a total of all of these different types of fees. I wouldn't want to create a variable that just said fee, and then have all these different types of fees. I would want some way to break those fees up into groups or types of fees. Maybe there is a late fee. Guys, ever experienced a late fee before? Those are fun, right? Or maybe it's your mind could go crazy with the different types of of definitions. But anyways, the point is, make the variable name self-describing. Never use like you would in algebra x or y or n. Make it something that is self-describing. And at the same time, you don't want to make your variable names too long. Can someone read that bottom line there, that variable for me? Yeah, that's crazy, right? That's nonsense. Can you imagine having to type that variable over and over again in your program? I would get frustrated trying to do that. So you have to have a good balance. We don't want to make all of our variable names abbreviated, but at the same time, it might be necessary depending on what the scenario is. Okay, let's talk about expressions. Your basic expressions. These are your mathematical expressions. Arithmetic expressions. So we have variables, and we can use literals. We'll talk about literals more. Literals are, for example, if I type inside of the system out print line and I put it in quotes and I type a string in there, that is a string literal, right? Other literals are just where I use the value itself and pass it around. Those are literals. We have operators. Operators are your plus, your minus, your multiplication, your division, modulus symbols, so forth. You'll notice that in Java that we use the star for a multiplier. You don't want to use an x. X will be confused as a variable, and the compiler will say, I don't know what x is. You didn't tell me what x is. Okay? We use parentheses. And so, for example, a literal is a specific value in the code like 2. So I have a literal called 2. Or there's another literal, 1. All right? Any questions? If you remember from last week, I talked about the syntax and the semantics. Some of this is syntax and semantics. You have to kind of get comfortable with it. And the only way to get comfortable with it is maybe mumble it to yourself or write it down or start using it in sentences, because it'll help you to remember what we're talking about. Especially as you go through the textbook, you're going to see these phrases over and over again, and you just want them to be second nature. Okay? All right. So when we're thinking about basic arithmetic operators, we have addition, subtraction, multiplication, division. You have the how the expressions are done. Remember, everything is left oriented. So y equals x plus 1. If x is 5, then x plus 1 is going to evaluate to 6, right? Basic algebra. All right? And we have that dear old phrase, was it please excuse my dear Aunt Sally? You ever heard of that before? Or maybe you have a different acronym for that. Well, look familiar? Order of precedence. It's the same rules. Okay, parentheses. We have what's called a unary. It's the same as a minus symbol. We have the next one that's evaluated is unary minus is different than the plus and minus down below. Okay, but the next one we have is the multiplier, the divider, and the modulus. Modulus may seem a little different to you. Modulus is basically when you're doing some type of division. Modulus is the remainder. Okay, so if I did 13 modulus 3, the remainder would be what? 1. And the shorthand for that is just 13 modulus 3. The way you do it on paper would be like, okay, 3 will go into 13 so many times. Oh, that's right. 4 times 3 is 12. 12 minus the 13. Oh, 1. In shorthand in Java, it's just 13 modulus 3. Finally, we have our plus and our minus. And again, everything in Java is done from left to right. It's assigned to the left, but you read it from left to right, just like English. Okay? The writers of Java and the writers of C++ and all of them, they were Western Europeans, and so they just, that's If it was Korean who probably developed it, or Japanese, maybe it would be a different order, or maybe in Arabic, but it's just the way the systems are divided, left to right. Okay. All right, special operators. We talked about this earlier. This is shorthand or compound operators. User age plus equals 1 is basically shorthand for user age equals user age plus 1. Okay, it just saves time in writing your code. You have other compound operators like minus equals, multiply equals, divide equals, and modulus equals. And you'll notice at the bottom that this will produce an error. In Java, you don't use any commas. You just have to make sure you're counting your digits if you're writing something out. Okay. There's really no way. In fact, I was reading an article on this, and the way they wrote the language, it would be too hard to try to do this string manipulation, convert it into a string, and then, yeah, they don't do that. Okay. So we talked about ints. Ints are non-decimal numbers. Okay. We also have a thing called floating point numbers. Floating point numbers is just a real number that a decimal point appears in. So for example, a float is equivalent to an int. Let's see, maybe I got that wrong. Float, I think, is equivalent to an int. Maybe it's the other way. Double is equivalent. We'll clear that up in a minute. All right, so example here, 98.6 or negative 55.667. These are all types of floats, and this is where the decimal point appears. A double variant stores the floating point number. A double miles traveled declares a double variant. So you have two types. You have floats and doubles that you would declare. And as you move on, you're going to find that we have actually what are called primitive types. Primitive types would be lowercase int, lowercase long, lowercase short, lowercase byte, lowercase bit, lowercase float, lowercase double. And then you have the object types, which are capital integer, capital long. It's literally the same, it's just a capital letter. And in Java we do that. We have this thing called primitives and objects, and we'll get into that later. So when you're using the scanner, you can read the scanner and it's going to interpret whatever comes in through that input, and you could say, well, I'm expecting a double. So you would say next double. Or you could say, I'm expecting an int. So I would say next int. Or if you're expecting a string, you would use next line, because they're reading the whole line. Okay. All right. So you typically want to choose the type of variable based on the value that's going to be held. Okay. So integer variables are usually for smaller numbers. And if you really want to make it even smaller, you could go to a short, but a short is even smaller in the number of bits it can hold. Typically we use integers a lot. Floating point variables, they're used for measurements like your degrees, anything with decimal points. Okay. All right, this gets into the interesting thing. In Java, dividing a non-zero floating point number by 0 is undefined in regular arithmetic. Okay. A lot of programming languages are going to produce an error, but in Java, Java doesn't. It just says okay, and Java handles it differently. It produces a infinity or a negative infinity. That's just what it just reads back out. So depending on the sign, so if it's signed, then it's a negative infinity. If it isn't, then it's a positive infinity. If you're dividing, you're probably going to see something. If you divide by 0, it'll produce something like, it'll say not a number, or in lowercase a, in, nan. Okay, not a number. All right, scientific notation. The way you would do this in Java is you use the e exponent. So for example, 6.02 times 1023, you would write that in Java as 6.02 E23. That's how you represent exponents in Java. In my whole career, I've probably done exponent, written them out as an exponent maybe once or twice. It's not used a lot, but it depends on the job that you're in. If you're in a job where you're crunching huge numbers, then yeah, you might end up using an exponent when you're talking about something in for floating point numbers. Any questions? We're going to buzz right through these, so just let me know. All right. So good practice is to minimize the use of literal numbers in code. This is what I talked about earlier by magic numbers. So for example, if I had the speed of sound is 761.207, and I had to write that everywhere in my code. Say I was using it for some type of mathematical operation and it was going to show up several places in my code. That's always a good sign to declare that as a variable and just put it at the top. And the way we do that in Java is we declare that variable as final. And I'm going to give you a special term. This is a very important term in Java. Anything that is final is immutable. Everyone say immutable. Right. Immutable is the opposite of mutable. So mutable means it can change. Think of like mutate. Immutable, once you create it, it's locked. It doesn't change. In fact, if you tried to reassign speed of sound later on, the compiler, it wouldn't even let you compile it. The compiler would say, I'm sorry, that is a final variable. It's immutable. We can't change those. Okay? So anywhere you have literal numbers in code, think about creating a final or a public static final, right? Variable. And you notice here at the bottom, we made it all caps with undercases, underscores. Okay? All right, any questions? All right. So some programs, they require the use of different mathematic methods, okay? And if you had to recreate all of the different mathematical operations like sine, cosine, floor, ceiling, average, it would get very tedious, okay? So Java has created many of these for you. They've got, for example, you've got math.square root. Anyone have a guess what that produces? You put in the value and it's going to give you the square root. And if you want to see what all of those are, let's see if I can go ahead and bring this up. This is the Java documentation for the math class. This is in the package java.lang. And if you remember, anything that's in the java.lang is automatically made available to your program. That means you don't have to write import java.lang math. Okay? It's automatically available. So there are a number of things in here that you could use. You have the absolute, returns the absolute value of a double, absolute of a float, absolute of an int. There's a lot of them. Sine, tangent, cube root, ceiling, copy sine, cosine, hyperbolic cosine. Is anyone here a math geek? You like anyone like math? Okay. Well, I was going to say this would be your, you would just have fun with this page, I guess. But no one's really a math geek, so. But if you ever need it, this is where you go. Okay. This will give you the documentation on it. Okay. And let's see if I can get back to the presentation now. There we go. So those are all your math symbols. If you have to do any type of special math and you don't want to have to remember the equation for sine or cosine or any of that, it's all available. All right, so integer division and modulus. We talked about this a minute ago. For example, 13 divided by 3 is going to equal 4. And the way it works with integers is it drops the decimal point. So if you're dividing with integers, it's just automatically going to drop the decimal point. It is going to give you what it is in decimal format. If you want to know that decimal point or the fraction of it, you need to use a float. You need to use a float or a double, because that will actually give you the actual decimal point of that number. So you may look at this and go, well, you're writing your code and you're like, man, where are the numbers going? It's off. We're losing money for our company because your code, right? You got to pay attention to that. Do y'all remember when the first Mars rover crashed into the surface of Mars? Anyone remember that in the news? It was over simple things like this. The programmers weren't doing the conversion right, and it was dropping. It was just forgetting the rest of the conversion. Bad news, right? So you got to pay attention to what you're converting here. So if you want the remainder, you'll use the symbol here that we have, 13 modulus. Don't call it percent, call it modulus. Get in the habit of calling it what it is. Modulus 3, that'll give you 1. All right, so type conversions. So we have a variable called num of births. It's 316. And then we have this algorithm below it, mathematical algorithm. It says double expected male births. We know that's double is a what type of variable? It's a decimal, right? Decimal point variable, right? It's a floating point variable. So double expected male births equals 0.504 times the number of births. Here, it will do the conversion. It's automatically combined and converted automatically. And this is, as the highlighted in the off yellow, it's an implicit conversion. If I did not have this declared as a double and I had int and I tried to do some type of division, it's going to just throw away the extra number there. Okay, so we have int to double conversion. So if I try to convert 25 to a double, it becomes 25.0. I have double to int conversion, and when I do double to int, this is where I lose precision. So if I had 25.2 and I converted it to an int, anyone know what number I would have? I would just have 25. I lose that precision. So we've got to be careful. All right. We also have typecasting. Typecasting is where you put the type that you want that variable to become in parentheses. So for example, here I have the variable my age is 48, and I have the variable years married is 27. Those are both ints. They're not decimal points. But down in my my math here, I say go ahead and convert my age to a double, and I do that by surrounding it in front with a double. Now this is okay sometimes with numbers. It's not okay when you try to do other types, because you can convert things to a lot of different types. And you have to be careful using this type of syntax. But here I convert my age into a double and the years married into a double. And so my age now becomes 48 point what? 0. And years married becomes 27.0 because I've typecasted them to a double. So now when I do the division, it's going to give me the percentage of my, of the years married. All right. Likewise, you can do double to int, but keep in mind you're always going to have loss of precision when you go from double down to int. You're going from a floating point down to something that can't contain a floating point. And because it can't, it throws away everything behind the decimal. All right. We also have another type of type. That came out nice. We have another variable type called binary. Binary is basically just 0 and 1. It's on or off. And we talked a little bit about this last week. This is like the switch on the wall. This is how we do things. So for example, we're familiar with the base 10. Base 10 is based on the fact that you have these digits. Everyone has, most everyone has, right? I almost lost a finger one time. I was cutting table saw with some wood, and anyways, 10 fingers, right? So this is just the way. I'm kind of going off a rabbit trail, but there's this actually thing in genetics where they talk about the dominant gene is actually 6 fingers versus 5. Did y'all know that? And just out of natural selection, everyone thought that was evil. And so there are people who have 6 fingers on each hand, and they decided we don't want to associate with them. And so they naturally selected out the dominant gene for 6 fingers. It's crazy, right? Anyways, not related to this, but if that was the dominant, then we would have a 12-base system. Could you imagine doing everything in 12-base? It'd blow your mind, right? So when you get to 12, you'd start the next unit of counting. All right, so our unit of counting on a computer is 0 and 1. We're used to counting in decimal base, 1 through 10. And so if we convert those numbers, we're having to shift bits on and off and add more bits in order to get to that number. That's important because when we talk about how we store characters, how big a number we can store inside of a certain type of variable, all of that matters, okay? All right, so let's talk about characters. So characters are different than strings. It's very common, guys. Every programming class I've taught is very common for everyone to confuse this. You'll notice that the character uses single quotes. Okay? In Java, we always use single quotes to refer to characters. When you're using strings, you use double quotes. Okay? So, for example, I'm saying here, my char equals single quote m. I would not say my char equals double quote m. In fact, the compiler will complain and say, no, you can't do that. That syntax doesn't make sense. The interesting thing is that the letters char are actually stored as numbers. And we'll talk about ASCII codes in a minute that deal with that. So if you're using scanner, you would say scanner.next, because .next is just give me a chunk, the first set of strings that are separated by space, and give me index number 1. Now some of you may go, no, you said index 0. And that's a special thing in Java. We count the first position for everything in Java starts at the 0 index. So in a string, if I want the first character is always at position 0. The second character is at position 1. The third character is at position 2, okay, and so forth. That could be confusing, but just kind of keep that in your mind, how that works. So here, if I want the first character from a scanner, and I say next dot character at position 0, that's going to give me that very first character. All right, any questions? I know some of you, I kind of blew your mind with that. You're like, that's going to be confusing. Yeah. All right. So a character is internally stored as a number. What? Yeah. So the character A is actually the number 97. Yeah. Let's take a look here. This is kind of the layout. You have the binary of what it is. The decimal is the number 32, and the character is what that is. So everything, if you look at the keyboard on your computer, every key in here is identified by a special character. Even the return key has a character because it's picked up. It isn't like what you think it means. You see, in programming, it's almost like the computer just sees one infinitely long line. And that doesn't make sense to us. We like to see things kind of organized in space, going this way, left to right, going down the page. And the way we do that with programs is we have these sets of binary characters that specify when the line ends, what a space is, a lot of things. In fact, there are hidden characters. There's a binary character for the escape key on your keyboard. It's all done in ASCII, okay? And if we click on this, go ahead and take a look at the ASCII table here. This is a small table. This was when the first computers were developed. This is what they used for representing Western characters, okay? And you can see that there's 127, starting at 0. It's interesting, if you think about it, from 0 to 127, that's really 128 individual spots. And let's do the math game here real quick. So if there are 2 bits, 0 and 1, we double 1, we get 2. We double 2, we get 4. Double 4, we get 8. 8, we get, I'm running out of fingers and toes, okay? 16, we get 32, 32, 64, 64, 128. Even the memory on your computers are done the same way. It all relates to that binary. Everything is done in those series of binary digits, okay? All right, so a little background history here. When they first started coming up with like the first computers, this is how they did it. They had, as you can see here, there is a carriage return, there's a shift, all of these things, okay? There's numbers, there's sequences, there's a character that signifies a bell. I think there's even one for a beep on here somewhere. It's a little hard to see. I know you guys in the back can really see it, right? Okay. So when this first began, it was only in English. And this was problematic because as computers started to spread around the world, what were the folks who spoke German going to do? Or those who spoke Norwegian, because they had these special characters. Or Chinese, or Korean, or let's say Thai, or Arabic, right? Everyone has all these different characters from around the world. And so ASCII became the very beginning set of characters used. And then from that, the next set of characters was called Unicode. And Java uses Unicode. So in Java now, you can actually specify every character sequence, whether it be a Japanese glyph, Chinese glyph, a Vietnamese, I don't know what they call their letters, right? Or the Thai script, or the Hindi script. There is a Unicode character set for everything now. And if you let that sink in, that'll kind of blow your mind. Everything that's available. Anyone here who uses a Korean key set on their keyboard from time to time? Or a Chinese key set? Has anyone done that? No? Right. They're all available. In fact, you can do that, okay? All right, so back to this. The way we specify some of these is with the escape character. So in Java, we use a new line character is encoded as the number 10. And the way we specify it on the page is single quotes \n. And that represents a new line character. So when you're creating a string and you want that string to wrap on the next line of your terminal, you'll use that new line character. Okay. Any questions? All right. So when we're outputting multiple chars, and we want them to be compiled into a string, we have to do some crazy stuff. Because if I put a char plus char inside of a system out print line without that double quotes there, what do you think it would produce? It's just going to add the numbers together. And that may not make sense to you. You're like, no, don't add it together. It's not now 97 plus whatever other character that is. So you have to put the double quotes plus and then that sequence. This is also important because say those variables are numbers and you think, oh well, I'm gonna have my string and I'm gonna say the string value is the addition of these two numbers. And then what it does is it produces, say C1 is 5 and C2 is 6. What would actually print is 56 because you have the double quotes. So the way you get around that is with your parentheses just around those characters. So it forces that addition first and then it will print. Okay? You guys understand? Some of you're like, I don't know, Mr. Rogers. All right, we'll do an example here in a little bit with that. Common error is to say char, my char equals X in double quotes. Can't do that. Compiler will error out. You got to do, when you declare a variable as char, you have to use the single quotes around it. Okay? All right. So then we get to string. And string is very special in Java. It's an object, but it's also kind of like a primitive. It's even stored differently in memory. They take the string literals, and every string literal you type is actually stored in memory as a separate value, because string text elements take up memory differently. And so they actually store that in this cache so that when they go to use the variable again, it's already in the cache and they don't have to take up another memory location. It's kind of interesting. All right, so strings, we have string literals. Example, system out print line. This is a string literal because I'm actually using the string instead of a variable. Okay. Yep. This is just what we talked about with variables and assignments. Let me go on past this. And let's now talk about circling back around to how we create variables, like integers. So an int variable, we just talked about this, is limited by a certain number of bits. And in fact, it's actually limited by 32 bits, an int. It may seem like a very large number, but as you can see, this right here, 4,294,967,297 is actually too big to be an int now. That is 33 bits. And it's namely, it fits in that sequence of bits below. Now, why that's important, when you get to numbers that you declare something as an integer, and an integer is 32 bits, but the number you're trying to store is 33, that 33rd bit will be lost. And I'll give you a little hint. In other programming languages like C and C++, you have to know this. Because if you don't, your program then becomes susceptible to someone who wants to hack into your machine. In C and C++, if there is an overflow, someone, like you declare a variable, and you have no way of controlling the number that's entered in for that variable, and someone from the outside says, Well, let's try to overflow it with a larger number. You can actually overflow programs written in C and C++ with a larger number and cause it to crash. And now you actually, what it does is it takes up another place in memory. It's outside the bounds of the program. So, I mean, you have to think about it as it's physical memory, and I've only specified this chunk of memory to be used, and if we don't do the proper checking, then the variable that it fills it up and it goes outside the physical memory and overwrites another spot, making that program susceptible to hacking. And that's really how a lot of the black hat hackers would abuse programs. They would try to do that. I've even seen it happen with some video game makers. Like there was, I believe, there was something in Mario Brothers where the same thing could happen, and they figured out that if they overran the number of coins to a certain bit, it would allow you to do some crazy things with the game. Okay, this is integer overflow. So let's go on. This is where the variable type is too long. So guess what they call the next variable above an integer? It needed to be longer, so they call it a long. All right. So a long is double the number of bits. Now, why do we do that? Because everything works in doubling fashion. So 32 bits is an integer. The next set of memory available above that would have to be double that, 64 bits. Okay. And you can even, although this is very rare, most programs that I wrote when I was in the Army, we used, for IDs, we used longs because we were generating at the time close to 1 million records a day for new Army applicants. And if we used an int, very, very quickly, by the end of the month, the number of records we were generating, we would actually overflow the amount for our ID. So we use longs for that. Okay, so one of the things you can actually do by accident is when you're doing a calculation, say this number is 1 billion, and this number is 1 billion, and this number is 1 billion. By the time you add all three of those together, you've overflowed the int capacity, even though your design is to divide it by 3, which will bring it down below. This will produce results. And you can do it in Java and it'll throw an error for you. It'll be a runtime error. It'll produce results, though, that won't make sense to you. So if you're doing that, if you have to use an int, make sure that you first do it like this. You say the number divided by 3 plus the number divided by 3 plus the number divided by 3. Otherwise, you need to use bigger variables. Okay? All right. A lot of this is just getting you aware of it. As you move through this class, this is going to make more sense as you start to applying it, writing code more often. All right, so we have ints and doubles. These are the most often used. But we actually have, in the way these are laid out, we have the byte. And the byte is made up of 8 bits. And the byte takes up 128 of bits of storage, right? Then you have the short. The short is double a byte, which is 16 bits. And then you have the number range. It's valid to negative 32,000 through positive 32,000. Then you have the int, which is valid from negative 2 billion all the way up through positive 2 billion. And then you have the long, which is I'm not sure what number that is. Okay. Just keep in mind, though, that we don't have a way in Java to render the commas. So you can't, if you're going to write a number down like this, you'll have to write it without the commas. All right, so then you have your floating point numbers. The float is like the int. Okay? It can take 32 bits. Negative 3.4 all the way through positive 3.4 times 10 to the 38th. Then you have the double, which is the same as the long, 64 bits. All right. Everything behind the decimal point is called the mantissa. All right. I know I'm putting some of y'all to sleep. Everyone stand up for a minute. Everyone stand up. I'm going to help you out here because this is just, I want you to keep some of this in your mind. If you got to do jumping jacks or, whatever. All right. You guys good?
Yes, sir.
All right. Go ahead and take a seat. All right. All right, so we're almost done with the lecture. We're going to jump into the next part here in just a second. Sometimes we want to generate random numbers, especially for those of you who are wanting to write games. This is how you do it in Java. You can do it through math.rand, and it'll generate a number which is 0.0 so many decimal points. You could do it that way, or you could do it through the rand, which don't forget for this one you'll have to import because it's in a different package. It's in the .util. So you'll say random as the type, randgen is your variable, equals new random. Okay? And if you use the randgen, you could do things like next int, and that'll give you a random number between -2 to the 31st all the way up to +2 to the 31st. Right? That may be a little bit too random a number for you. So what they've done for us, which is very nice, is you can specify the range. So I want a number between 0 and 10. And what that would give you is a number either starting at 0 up to a max of 9. Remember what I said before about everything starting at 0 and moving forward? This is the same process here. If the random number is not random enough for you, you can actually seed it with a special number. And so here I'm just seeding it with 5, but you could specify anything you want. You could specify the system time clock in milliseconds as the random number generator. Interestingly enough, when a lot of the programs were like Pac-Man and Donkey Kong, they used a random number generator that they thought was random. But really what it is, a random number is actually just a repetition of a very large sequence. And the way they do it in Java is they take the system time. And that system time then is basically repeatable, although the scale of it is so massive that it feels like it's not. But back in the early days, the Ghost, Blinky, and all those others would always seem to come out at a certain time at each level. And a lot of gamers realize that, and they're like, well, no, it isn't random at all. Everything is happening at a specific time. So it's pseudo-random, but the fact that they use milliseconds, which is like it's long type, it's 64 bits. The number is so huge that it's very hard to predict what it is. Unless you have a supercomputer, then you might be able to predict what the random sequence might be. All right, API documentation. There's a link here if you guys want to look this up. You can basically just type docs.oracle.com. And this is of Java 12, but we're at 17 now, and I think coming up this summer we're going to be at 19. I don't know why we're skipping a level, but we're jumping. Everything in Java it's an API. It stands for Application Programming Interface. Your documentation is stored in modules. The modules are kind of like the package names, like the Java util, right? Math or Java util random. That's a module that has a bunch of classes associated with it. Packages are groups of classes, and so forth. Okay. All right. Debugging. Debugging is basically where you write some code and you just kind of step through it. Something isn't working and you just kind of start breaking your code down step by step. Maybe putting some system out print line statements in there, saying, okay, what is the value at this step? All right. Well, what is the value at this step? And kind of moving through it. We're going to be looking at how you can debug in Java, in IntelliJ. IntelliJ has a fancy debug feature where you can actually hover your cursor over the value as it steps one line after another. It'll pause execution, is what it'll do. And you can actually check the value of your code as you're stepping through it. Has anyone ever used a debugger before? Debuggers will become your best friend because I guarantee some of you are going to get angry. You might throw your laptop across the room because you're getting mad at your program. And don't do that. Use your debugger, and you can debug through it. Okay. So what I want you to do, go ahead and break out IntelliJ in your on your laptop. If you're using the desktop, I think they put IntelliJ out there as well. We're going to go ahead and do the lab that is due at the end of this week, like Sunday or Monday. This is to kind of help you all get a step forward with it, okay? Once you get IntelliJ open, just let me know, because I want to make sure that we're all at the same pace as we move forward here. If you get to this screen, let me know, okay? I'd really like us to do this together so we can kind of stay on target today. Now, while we're doing that, I'm going to go ahead and pull open the lab. I'm going to wait for you guys to just go ahead and get your IntelliJ IDE open, and then I'm going to pull open the lab so that we can kind of look at the requirements together. I'm having to do this off my phone, so for whatever reason I couldn't join the Wi-Fi today. This is lab 226, okay, and we're going to create a function, a program, to calculate calories burned during a workout. Those of you who have, like, last semester, some of you did a website talking about your fitness goals and things like this. This is actually the source for this code. This algorithm is it's taken off one of the Science Health sites, and we're just going to use that algorithm and then write some code to populate it. Okay. The source for it, it's found in this scientific journal article. We'll go ahead and open that in a new tab, so if you wanted to see it. It's going to take a long time. This is the source for the, if you guys want to read the Science Journal article, but it's buried down in here somewhere. Anyways, so what we have to do is we have to create this algorithm right here. This is taking the age, the weight, heart rate, and by the amount of time of your exercise. And they're multiplying it by different factors. And then we're going to print it out using the printf function. Printf is the print format. You're going to find out about that last week or this week, I'm not sure, in your class. The way the print function works is we specify how the format is basically what it does for us. Zybooks is going to test based upon these following inputs: 49, 155, 148, and 60, which basically corresponds to, I think, an age, a weight, a heart rate, and a time. Okay? And then the output should be this when we're done: 736 calories. That's a good workout, isn't it? Burn that much calories. All right, so here is the class that we need to come up with. It's called lab program. So I'm going to go ahead back to IntelliJ. I'm going to create a new project, and I'm just going to call the project lab program, and this is lab 226. I'm going to put 2_26, because maybe you want to come back and review this later on, right? Okay. I'm going to select Java as my language, and IntelliJ, and that's it. Let's see here. Make sure that you're using Corretto 17. Okay. We'll create the project. And it's created a main class for us. Now, according to Zybooks, the class here needs to be called lab program. So I'm going to copy that. I'm going to right-click on main. And I'm going to go to rename it. Paste that in. Now it's renamed the class, the file, and the class name. Can you all see that? Okay. IntelliJ put in this public static void main for us, and it has a hello world. It's very nice of them, but I'm just going to delete the hello world. Get rid of that. Okay. Let's go back. We can see that we're going to use the import Java util scanner. So I'm going to go ahead and go up here, top of my class, include that import. Okay. Now, for our own sake, let's go ahead and copy some of this information. We're going to need this algorithm, this equation for use. And I'm going to paste it inside of here with a comment. Okay. Let's drag this over a little bit. Actually, if you double click on the title, it'll do that for you. Okay. All right, so I need to collect these inputs. So first things first, let's go ahead and create our scanner. And let's say new scanner. And inside my scanner, it's going to take a package and a class name. Do y'all know what it takes? Anyone remember? Yep, system.in. Okay. So we need to declare some variables. And if we look at this, we need to write a program using inputs for age, years, weight, pounds. Heart rate is beats per minute, and time in minutes. Okay, so I'm just going to copy this over so I can keep it all in one place for me. Okay. All right. And just so I can see everything, I'm just going to do it like that for right now. We'll take out this code in a moment, okay? All right, so I need to write a program that inputs age as years. And because we're doing a calculation with percentages, I'm going to go ahead and create my age as a double. I'm going to say age years. And I'm going to put the semicolon on it because we're going to input that data later. I'm going to create another one. This is weight pounds, okay? So the weight in pounds. We'll create another one. And this is heart rate, beats per minute. Let's just say heart BPM. We have another one. And this is our time in minutes. So say time, minutes. Okay. Let's see. What else do we? I think we have another value here, don't we? Yeah, and then of course we have to have our calories, right? This is what we're outputting to. Okay. You guys with me so far? Okay. So let's do the first one. Let's populate our age years. So we'll say age years equals scanner, and age years is a double, so we're going to say next. What kind of next should we use? Huh? We could use line, but line is going to give us a string. We want something that's going to match our declared variable type.
Next double.
Yep, next double. Very good. Okay. Do the same thing for weight, pounds. Say scanner, and we'll do next double again. Heart, BPM. Scanner, next double. And you can tell all of these are double up top. All of these are. So it means that we're going to use next double for all of our values. Time, minutes, scanner, next double. And now we get to the point of our calculation. All right, so if we look at this line up here, we already have pretty much the entire calculation that we need, don't we? All right, so what I'm going to do, I think I can just copy this. Let's just do that. I'm going to copy it, and it is a mess. So let's first of all fix our first variable, calories, and then we'll fix this next variable, age, with age years. Can't use the X, I have to use the asterisk. Weight, pounds, we'll copy that one, paste it in. Again, replace the X with the asterisk. My heart rate, place what we have here. Fix the asterisk. Okay. You guys let me know if I'm going too fast here. That minus symbol is a little weird, so I don't know what that was. I think that was some other character sequence. Make sure you fix that minus symbol because what's copied from here is I think a dash, not a minus. So you got to retype it. And then we'll fix this X. Whoops. There we go. And then our time in minutes was that. So we'll take that, do there. And then what am I missing? Semicolon. Okay, so we got that. Now, if we go back over here, it says we need to use this symbol, right? Your value. So we're going to paste this in, and it looks like we're going to copy calories and put it in there. Let's take a look at this. So here's the output below, right? You'll see the output. It needs to print that. So we're going to have to modify the method here so that it prints this text. So it means that right here we're going to say, use a string literal, calories, right? And I'm going to give you a little hint. The %.2f is automatically replaced when using the printf method. So it's going to take this value and swap it over top of this. Okay? So what we want to do is we need it to end with the value and the number. Okay, the value and the number. So if the value is automatically going to swap in here, this means that right here I would say calories, and we need to do that for a new line character at the end. So this variable here is automatically going to come in here and replace that this data, okay? And it's going to format it appropriately. All right, what's the last thing we need to do? We need to input this information. So I'm going to copy that, come up here and paste that in. Let's go down to our terminal. And I'm inside of the lab 2_26 program, right? Did everyone see what at the bottom? I'm not covering anything, am I? Everyone's got this so far? Okay. So I'm going to cd into source. And now there's the lab program. So I'm going to type javac lab program. Hit enter. If I do an ls, I can see that the lab program class exists. So let's go ahead and execute it. We'll type java lab program. Okay, now it's expecting those inputs. So what were my inputs again? 49, 155, 148, and 60. Let's see if I wrote my program right. Does that match? What is the 736.21 calories? 736.21 calories. Cool. All right. Now, that is your lab 1. I'm going to give you a little hint. In zyBooks, when you run this test, okay, you put it in here to submit it, it might complain and say that something is not spelled right. Or it might complain and say that the variable is not spelled right, okay? It's testing based on exact measurements, okay? Raise your hand if you used zyBooks before. Anyone use zyBooks before? Yeah. Those of you who have used it before know what I'm talking about. It's a little frustrating, so make sure that you pay attention to the testing. So I'm going to go ahead and take what I've got. I'm to copy this, and I'm going to paste it in. Okay, so we got develop mode. Let's try submit mode. Develop mode. There should be a thing in here to run the program. Where did it go? Oh, here it is, run the program. Your code requires input values, provide them here. All right, so we're going to provide the input values. We'll take those values, paste them in here. We'll run the program. Okay, and it's producing what it's supposed to produce. Okay, so if it's producing, then what you need to do is go to the submit mode and submit it for grading. Now this is the part where it'll probably kick something back and say something needs to be changed here or there. Okay, in this instance though, if you did it exactly as I did it, you should have 5 out of 5 for both sections. Okay? Yes?
So on your IntelliJ, when you first ran the terminal, what did you type out first?
Oh, when I came in to open it up? All right, so you'll notice right here, this is where I'm at right now. But when I opened up IntelliJ, the terminal, I was actually right here at this level. And I can't compile the program unless I'm at the class level. So I had to type cd source. Now I'm at the source level. Okay. I have to be at this level when I type ls, or if you're using a Windows box, dir, right? It doesn't recognize dir on a Mac, but you have to be at the same level as the Java file, because what you do is you type javac lab program and then it compiles it. Okay. This help anyone today? All right. There are, if we look at the assignments, guys, you have a random numbers challenge activity. Let me go back to the week here. Excuse me, the assignments. Here we go. You have a random numbers challenge activity, a type conversions challenge activity, a constant variable, floating point, right, arithmetic, and so forth. These assignments are going to be much different than the lab itself. All right. It is 5:02. You guys are good to go. I will take the video today and upload it, so you guys need to review it. You can.